Hello, all, very warm welcome. Today we are looking at another LeetCode question, which is valid anagram, and we'll try to solve this problem using Python. Now, what are anagrams? So we are given two strings S and T, and we need to write a function to determine whether T is an anagram of S or not, right? So if I take an example, right? Say star, right? Star is a anagram to rats. Why the anagram? Because these two are formed using the same set of characters. So if I jumble upon these words, right, TSAR or ASTR, these are all anagrams. STRA, because I can form one word from the other, right? These are all anagrams to each other. So this is very simple and crude example of okay what is an anagram. And what we have to do is, if we given the two input strings, if both are turning out to be the anagram to each other, then I need to return true. If they are not, then I need to return false, because in this case, if you see, rat and car are not anagram to each other, because irrespective of however I jumble rat, it is not equal to car, because I have a letter C which is not present here in S, and I have a letter R which is not present in word T. Right? How will I approach this problem? So I'll 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 go ahead and try to kind of uh, go through these number of words which are there, number of characters which are there in letter S, and I'll store that in a hash map, and hash map, or you can say dictionary, and I'll maintain a count of it, right? So if say I have say stars, right? What I'm going to do is, okay, S is 2, T is 1, A is 1, and R number of characters in R, the count of R is 1, right? Now what I'll do is, now if I go and check, say, rats, right? Rats for that matter. What I'll see, okay, in my current dictionary which I have, do I have a R? Yes, I have an R. What I'll do, I'll reduce the count of it. So this becomes 0. Now, do I have a A? Yes, I have a A. I'll reduce that to be 0. I'll reduce the sum of it. Do I have a T? Yes, I have a T. I'll reduce it. Do I have a S? Yes, I have a S. I'll reduce it. Now the updated sum is 1. Now, with this I finish this iteration. Now, once my iteration is done, what I will see? If any of the numbers in dictionary, if any of the if count in dictionary is not equal to 0, that means it's not an anagram, because ideally if they would have been if ideally these two would have been anagram, I would have had another S associated to it, and then in the next run it would have moved to 0. These two are anagrams to each other, but these are not, right? So let's jump to the code and try to see how we'll approach this. So first we'll create my dictionary, which will be uh, a simple declaration. Now first thing first, yes, if they are anagram to each other, the length of them will be same. If not, then we can just directly return, sorry, right, directly return say false, right? Now we have ensured, okay, length are same. Now what we'll do is, we'll start storing the sum in uh, in a dictionary. So let's run it across. So for C in S, for say character CH in S, what I'll do is, I'll say if my CH is in dictionary, my dict, right? What I'll do is, I'll do my dict dot update the value CH with the updated value CH plus 1, right? Else I'll just say my dict dot ch is equal to 1, right? This is how I'll keep on updating the values to it. Now I have my dictionary updated, right? Now I'll go through and loop see whether the same set of characters are present in the letter T or not, right? So again, it's almost the same condition. If my ch is in my dict and my dict dot say ch is greater than 0. Why? Because I don't want to go ahead and keep on subtracting the items even though they are less than 0, right? I'll do my dict dot update ch my dict ch plus 1, sorry, in this case minus 1, else I can straightforward return false. I don't need to iterate further because I know that okay, this character is not in the dictionary which is I'm finding right now, or its length is already less than 0, right? So these two runs have ensured two things. One, uh, after completion of these two runs, one, my dictionary is still having a value, is either still having a value which is greater than 0, or all of my characters have exhausted the values and they are equal to 0 now. To ensure that we are not missing out anything, what we'll just do is, okay, I'll just go and just have a quick check into my values in the dictionary, and I'll just say, okay, if D is not equal to 0, right, I'll just return false. And if the whole iteration completes, right, that means this turns out to be an anagram. Let's run it. This returned that's true. Let's submit it. It passed. So this is one solution. We can also do in one iteration, that we can combine one iteration. We can go through, say, the range of the length if they are not same, and then we can add and subtract at the same time. So there are various ways in which we can kind of perform this solution. But overall, the idea remains the same. With this approach, that okay, I always maintain a count of how many characters do I have in a given string, and I try to compare the same number of counts in the target string whichever is given to us. So the complexity is, if you see, we have used only one loop which is going to iterate through the length of the string. So that will be O of n, and we are using a dictionary, so that will be O of n times space complexity as well. Uh, so I hope you liked the solution. In case you did, please go ahead and like and subscribe. Thank you guys. Thanks a lot.